All right, let's jump right in. If you've ever sat around waiting way too long for a Docker build to finish, or maybe wondered why your super simple app is somehow taking up a gigabyte of space, well, you are definitely in the right place. Today, we're totally demystifying the Docker file. We're going to treat it exactly like a high-tech manufacturing blueprint, where every single instruction is a crucial step on an assembly line. Let's transform those slow, bloated images into highly optimized containers. Here's the game plan for today. We're moving through 4 critical phases. First, the essentials for setup. Second, action commands and layer optimization. Third, wiring it up with configuration. And finally, the finish line, execution. Real quick, before we start the line, let's just make sure we're on the exact same page with our vocabulary. A Dockerfile instruction is basically just a command, always written in uppercase, that dictates how to build your image. But, and this is the absolute secret to everything we're about to cover, every single instruction you add creates what's called a layer. Think of a layer as a cached file system modification. Understanding how these instructions create these individual stackable layers? Yeah, that is the ultimate key to building lightning-fast, secure containers. Okay, phase 1, the essentials, setup instructions. So, these instructions lay your groundwork, and from is absolutely the critical first step. It sets your base image. And honestly, picking a tiny base image is your first immediate optimization win. Like if you use an Alpine Linux variant, say Node 20 Alpine, you're getting a full, tightly controlled Linux distribution that is literally under 6 megabytes. Crazy, right? Then we've got workd. Please, use this instead of trying to hack together CD commands. It sets the working directory for everything that follows, making sure it all happens in the exact right folder completely safely. And finally, label. This is just for adding helpful metadata. Think project organization, license details, or, who the maintainer is. Moving right along to phase 2, action commands and layer optimization. Now we've got 2 main ways to actually get files from your machine into the container: copy and add. And what's kind of fascinating here is how identical they look, but how differently you actually need to treat them. The bottom line, you should almost always stick to copy. It is the gold standard for standard, transparent file transfers. It's predictable. You really only want to reach for add when you specifically need its superpowers. See, add can actually fetch files directly from remote URLs, like grabbing a .NET installer, and it can automatically extract .tar files right during the build. But seriously, if you don't need those specific tricks, just stick to copy. Okay, so your files are in. Now you need to actually execute commands to put the app together, and that is where run comes in. You use run for build time execution, like run npm install or run apts install python. But hey, remember our vocabulary from a minute ago? Every single run command creates a brand new layer. So if you casually drop 5 run commands in a row, boom, you just created 5 new layers, and you are actively bloating your image. The pro trick here is chaining. Chain your commands together using that double ampersand operator. It groups multiple commands into one single clean layer. Huge optimization. Actually, let's pause the line for a second, because this chaining concept perfectly illustrates how Docker layer caching actually works. And listen, this is the literal secret to getting those 10x faster builds. So Docker reads your instructions sequentially, top to bottom. For every step, it checks, hey, has this instruction or have these files changed? If nothing changed, awesome. It reuses the cache layer from your last build. It's basically instantaneous. But, and this is a massive but, if a layer has changed, Docker throws out the cache and rebuilds that layer, plus every single subsequent layer that follows it. The cascade effect is real. That's why the structure of your blueprint absolutely matters. Put your rarely changing instructions, like core packages, at the very top, and your frequently changing stuff, like your active source code, way down at the bottom. Let's look at what this actually looks like in practice. Check out this terminal output. What's really cool is you can literally see the CLI skipping over steps. See that word cached right there next to the workdir step? Because that specific instruction didn't change, Docker just completely bypassed rebuilding that layer. It saved them a massive amount of time. If you organize your copy and run commands properly, your continuous integration pipelines are going to absolutely fly. All right, phase 3, configuration, wiring it up. Every app needs variables, right? And Docker gives us 2 distinct flavors, env and arg. Choosing between them basically just comes down to visibility. You use env when your actual running application needs to see the variable, like setting node_env to production. But here is the catch. Every env line creates a permanent intermediate layer.
Even if you try to unset it later down the file, its value can still be dumped. So absolutely do not put highly sensitive production passwords in an env instruction. On the flip side, ARG defines variables that exist only during the build process. Once that container spins up and is running, ARG variables are totally invisible. So they're absolutely perfect for temporary build secrets or passing in a version number during the build itself.
Another one you'll see a lot is expose. You use this to document which ports your container will listen on, like expose 8080 for a web server. But I cannot stress this enough, expose is purely documentation. It's just a friendly note to other developers telling them how the image is supposed to be used. It does not actually open or publish that port to your host's machine. You still have to manually map the ports using the -p flag when you actually run the container.
Finally, we made it to phase 4, the finish line, execution. How you actually type out your final execution command fundamentally changes how your application behaves inside the container. You basically have two choices, shell form or exec form. Shell form looks just like standard terminal typing, right? CMD, npm start. But under the hood, Docker takes that and wraps it in a separate shell, like /bin/sh. And because it's wrapped up in that shell, your application is no longer the primary process. It's not PID1. That is exactly why the exec form is heavily, heavily recommended. It looks like a JSON array. Brackets, quotes, the whole shebang. This tells Docker to execute your application directly, no shell involved, making it PID1. And that is crucial because it means your app can actually receive Unix stop signals from the host OS, which means it can shut down gracefully. Bottom line, always use the exec form. And that brings us to the ultimate showdown, CMD versus ENTRYPOINT. Both of these execute your application, but they come at it from completely different philosophies. ENTRYPOINT defines the primary command that is always going to run. If you want your container to behave exactly like a specific, unchangeable tool, like, say, a Python script where the user is only supposed to pass arguments, you lock that down with ENTRYPOINT. It is super stubborn. You can't really override it unless you explicitly force it with the --ENTRYPOINT flag. CMD, on the other hand, is all about providing flexible defaults. It's incredibly easy to override. Like, if your Dockerfile says CMD npm start, but a user types docker run my_image sh, boom, your default command is totally wiped out and replaced by sh. Now here's the real pro tip. The best practice is usually combining them. Use ENTRYPOINT for the unchangeable main executable, and then use CMD right after it to provide default parameters that the user can easily swap out if they want to.
So there you have it. From the from setup through all those copy and run optimizations, into the configuration wiring, and right across the CMD and ENTRYPOINT finish line. Your Docker file isn't just a basic text file anymore. It's a meticulously engineered assembly line. Now that you've got the mechanics of layer caching, instruction selection, and process execution down, I have a challenge for you. Go audit your own repositories. Seriously, are you taking advantage of Alpine? Are your copy commands ordered the right way to actually hit that cache? Are you strictly using the exec form? Take a hard look at your blueprints. Is your Docker file a finely tuned machine, or is it kind of a junkyard of wasted space and missed optimizations? Go check out your repos, and let's start building better